All right, ladies and gentlemen, today we're talking about least common multiple. I kind of had to cut off the top here, so if you want to put your name in it, that's great. If not, that's cool too. I would at least jot your name down here, so if it does get dropped, you know which one's yours. So, today we're talking about least common multiple, or LCM. Again, this is something you have seen before, so this should be mostly a review for you. So, least common multiple is going to be a multiple, or something that two things can get to when they're multiplying, that they have in common, and it's going to be the smallest number of those. Kind of like the opposite of GCF. So, when we're trying to do our multiples, first thing we're going to do is, there's two ways to find LCM. The first way is to, of course, list your multiples. If we're going to do that, we're going to list the first 6 multiples of each number. So I'm going to show you that first, this method, down here in a second with this 12 and 24. Once we list our first 6 multiples of each, you're going to circle the ones they have in common. And I'm sorry, this should say multiples, so can you change that for me? So the multiples they have in common, the least number circled will be the LCM. Unlike GCF, this is actually probably the easiest way to find LCM. So, listing multiples of 12. I know 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60, and 12 times 6 is 72. If you're not sure of what they are, really all I'm doing is adding 12 each time. My other number I'm going to list for is going to be the number 24. When I'm doing 24, I'm of course going to start off with 1 times 24, which is 24. 24 times 2 is 48. Most people might recognize, oh, I could have already stopped because I already have things in common, but I'm going to list the first 6 just to show you. And then 96, and then 120. So those are my first 6 multiples of each number. Again, as you guys get good at this, you'll probably only need to list the first 6 multiples of the smaller numbers. Sometimes you might need to list more than 6. You just keep going until you find multiples they have in common. Here, I should notice right off the bat, they have 24 in common, they have 48 in common, they have 72 in common. If you recognize this pattern, you should know whatever comes next would be 96. But their lowest number they had in common was 24. So my LCM equals 24. That's not always going to work out that your LCM is going to be one of these two numbers. So today, I'm going to go ahead and I'm going to have you try this out, doing the second way though. The other way to do this is to, of course, use prime factorization. When we do that, we make factor trees. To find the prime factorization, which is a video you've already watched. Then we're going to write the prime factorization, and when we do this, we're going to write it using exponents if possible, which wasn't on the video, but we practiced that in class together, if you remember. We talked about combining the ones that were alike to write them as exponents. This is where it gets tricky. The wording on here is going to sound kind of strange, so I want you to go ahead and use the wording, but then I'm also going to have you watch the example. So, to do that, you're going to multiply all the factors using only the one with the highest power, and you're going to multiply those to get the LCM. Again, this sounds really strange, so I'm going to have you watch it. So, factor tree, starting off, we're going to do 12, and I'm going to go through these quick. 2 and 6, that is prime. 3 and 2, those are both prime. So for 12, I have 2 times 3 times 2, and I didn't even follow my own rule. So I'm going to have 12 equals, using exponents, I have 2 times 2, so 2 squared times 3. All right, I'm going to do one for 24. 24 is 12 times 2, that is prime. 6 times 2, that is prime. 3 times 2, those are both prime. So for 24, I'm going to write it. Actually, I'm right here. I'm multiplying 2, 1, 2, 3 times. So I'm going to write 2 to the third power. I'm only multiplying the 3 once. All right, so here, I'm going to have to use a 2 and I'm going to have to use a 3 to find LCM. It doesn't matter which 3 I use because they're both just a plain 3. So I'm going to write 3 times. Here, I'm only going to use one of these 2's. 2 to the second power, 2 to the third power. I want the one that's the highest power, so I'm going to pick 2 to the third. And that's going to equal my LCM. So first I got to do my exponents. 2 times 3. 2 times 2 times 2, or 2 cubed, is the same thing as saying 8. And I have to multiply that by 3 to get my LCM. And we're going to know 3 times 8 is going to be 24. All right. To be very, very honest, you're going to have to do both ways for all of these today. Your problems are on the back. I don't have them printed on the back, though. But I'm also going to have you guys do one that's kind of tricky. I'm going to have you do one that's 3, 6, and 9. So it's 3. So let's go ahead and start that out. We're going to first try it by listing factors. Oh, you're going to pause it and try it, and then hit play. Okay. So for 3, we got 3, 6, 9, 12, 15, 18. I could keep going, but I'm going to stop there because usually the first 6 will give me a common factor. Usually, not always. Now I'm going to do 6. 6, 12, 18, 24, 30, 36. And then for 9, 9, 18, 27, 36, 45, 54. I know my facts off the top of my head, which is why I'm able to do this so quickly. This time you have to circle things that all 3 have in common. For example, 3 and 6 both have 6 in common, but 9 does not. The only one here that I see that all 3 have in common, that is my lowest one, is 18. So I'd know off the bat my LCM equals 18. Now we're going to try using factor trees. If you haven't paused and done that yet, I want you to pause it now before I go on to it. Okay. 3 factor trees, and this should be easy because right off the bat, 3 is prime, so I don't have to do anything. So my prime factorization for 3, I'm going to write right here, is going to be 3. Then I'm going to have my prime factorization for 6. 2 times 3. Those are both prime. So for 6, I'm going to have 2 times 3. I don't need any exponents because I don't have any exponents to use there. And then for 9, I have 3 and 3. So I'm going to write that as 3 squared. Okay, so now the factors that I have here are 2, and this is the only 2 I have, so that's the one I'm going to use. And of course I have 3's. This 3 and this 3 don't have an exponent, but this 3 does. So I'm going to use that 3 to multiply. So I'm going to have LCM equals 2 times 3 to the second power. Because of order operations, I'm going to do this 3 to the second power first. 3 times 3 is 9. So I'm going to put 2 times 9. And then I should know from there that 2 times 9 equals 18. And I'll box up my answer like a nice little present. Okay. You guys have to do the LCM both ways. Listing factors and doing factor trees for each problem. See you tomorrow.